All right, welcome to this video on symmetries that deal with reflection symmetry, rotation symmetry, and translation symmetry. There's a note sheet that goes along with this, your blue note sheet. If you could take that out, it has the shapes on the back side, and it will help you with the names that we use. So there are 16 different shapes that we have as our main toolkit list of shapes. We have hexagons, kites, rectangles, scaling triangles, trapezoids, equilaterals, squares, isosceles, circles, rhombus, quadrilaterals, isosceles triangles, scaling right triangles, isosceles trapezoids, parallelograms, and regular pentagon. So as we go through all these shapes, make sure you are aware of what reflection symmetry means. If you think back to when you have mirrors, mirrors show the same thing on both sides. You always see your same exact replica of yourself. In the mirror, when you look into it, if you put a line of symmetry down the middle of this hexagon, you can see that I have the same thing. So what we have here is called a line of reflection. So if I have my line of reflection here on this actual hexagon, I can put a line right down the middle of it, and that's one of the lines. You'll be asked today, how many lines of reflection does your shape have? Well, we know that there's at least one, because I just put a mirror there, and we saw the same thing on both sides. However, there are more. You could also have one going diagonally through the vertices as well. If I put my mirror right along this dotted line across this, that will also give you the same thing on both sides. So your eyes have to be able to look at a shape today and say, how many lines of symmetry does it have? And there you can see again that if I put a mirror right on that spot, you'll see the same hexagon that we had without that. Now, there are still more. You got one that goes this way. There's 3. Here's 4. And then here's 5. And then lastly, here's 6. There are 6 lines of reflection on a shape that has 6 sides. You will see a correlation with that. So this has 6 lines of symmetry. I'll start to abbreviate this here in a minute, but L-O, and I'll just say symmetry like this, okay? There are 6 lines of symmetry on a hexagon. Let's fast forward to other regular shapes that are in this list. You'll notice that there's a square here. That's going to have 4 lines of symmetry. I'll just say 4, and I'll just say LOS, lines of symmetry. Next one, there's another shape in here that I want to talk that's regular, this pentagon down here. This pentagon's got 5 sides, so it's going to have 5 lines of symmetry. Oh, let's go LOS, I guess. Lines of symmetry as well. Next, as we look at shapes that aren't going to be regular, that have same angles, same length sides, we have a kite. Put a mirror down the middle of this. It has 1 line of symmetry. That's the only place I can put this and get the kite that you see in the picture. So this has 1 line. And then other shapes you'll find may have 2, maybe have 3, and whatever it might be. But in this case here, you're just trying to think of, on your shape, which ones have lines of symmetry. This kite has 1 line of symmetry. I'll just call it LOS again. Next, and then this one right here has 2 lines. You can put the mirror right there, and you can also put the mirror right here and see the same thing. So rectangles have 2 lines of symmetry, as you see like this. So lines of symmetry, I hope you start to see how this all kind of works. Where you can put a mirror, there are some shapes that you're going to be tempted to maybe say that they do have lines of symmetry, but a scaling triangle, for example, if all the sides are different lengths and all the angles are different lengths, there's nowhere you can put a mirror and get that same looking shape. Scaling ones don't work. This trapezoid here, it would be nice, but it doesn't work. You can get one that kind of looks a little bit like it, but this side's shorter than this side, so you can't put a mirror on this one. Other things to note, the parallelogram is one that might look like it has symmetry as well. That's a typical one that students would say, hey, does that have lines of symmetry? And you can put a mirror here, but you don't see a parallelogram. You can try putting it diagonally. You get like an arrowhead. Not going to work. So there's nothing you can do on a parallelogram for lines of symmetry that are going to make that work. So lines of symmetry, again today, where can you put a mirror and see the same thing on both sides? Again, when it's regular, if it has 6 sides, it'll have 6 lines. Square had 4, pentagon had 5. All right, moving on. That's what we call reflection symmetry. The next topic you need to be aware of is rotation symmetry. As you look at these shapes, the same shapes we just talked about, we'll say, does it have rotation symmetry? Now, I've put a little dot in the corner of these so you can actually see this thing rotate, but we're saying how many times does this thing snap into place? So if I turn this hexagon a little bit, it snaps back into place when it looks like this. That was one little turn, and that made it still look like a hexagon. And you turn it again, it snaps in place again. I can do that 6 times, it'll snap into place till that dot is back to the beginning. So this thing has an order of 6, as it's mentioned sometimes in some websites about how you describe the rotation symmetry. But in our class, we're going to talk about how many degrees do I rotate this thing until it actually hits the next line. I'm sorry, until it snaps back in place. And in this case right here, if you rotate this thing from here, where that dot was, to right there, you'll do that 6 times. If you take 360 divided by 6, you'll get your degrees of rotation. What that is going to end up equaling is 60 degrees is what the rotation symmetry is going to be in this one. In this kite that you see here, as I rotate this thing, it never snaps into place. So you would say it does not have rotation symmetry. You can say 360, but 360 degrees is nothing special for a shape when it turns all the way around. Now a rectangle, it's got what's called point symmetry, but we're going to just stick to the sake of how many degrees do you turn it before it snaps back in place. So this rectangle, I can turn this one as well, and you'll notice it turns 180 degrees, and then it snaps back into place. Oops, and then it snaps back into place. So keep in mind what it takes for a shape to rotate around, and you'll find that this one here rotated around 180 degrees. So the degrees of rotation here is 180 degrees. Scaling triangle, if it's ever going to have all different sides, different length sides, there's nothing similar about this thing as you spin it. So that's like a spinner on a game that you play where you flick the spinner and it spins. This is never going to snap into place the same way a hexagon can. So this has nothing also, so you're just going to say 360. As you try a trapezoid, this thing has some different length sides as well, so that's just going to be 360. If you see the equilateral triangle here though, the equilateral triangle, it has its own shape as well, and that can snap into place. If I take my shape right here and rotate that, it'll snap back in place when it goes to right here. So that means you can do that 3 times. So if you take 360 divided by 3, that will give you a degree rotation of 120 degrees. That's how that works. Squares, you can see now if it's got this little corner here, it's going to snap in place 4 times. So just take 360 divided by 4, and that gives you an answer of 90 degrees. This one looks tempting to want to say it has rotation symmetry, but when you keep turning it, you never get it to snap in its original position. So you actually have to go all the way around before it even does that again. So this one actually only has 360 degree rotation. Now I've only done some of these shapes right here. You can figure out the rest. There is one special one here, the circle. The circle actually has infinite degrees of rotation. You can turn it just a little, or you can turn it a lot. It doesn't matter how much you turn it. So this one really, we'll say it has infinite degrees of rotation. And the rest of these, I think you can all see how they work. So hopefully you understand a better sense of degrees of rotation, or rotation symmetry. And one thing to also note, this thing back here, as I mentioned earlier, this has 6 lines of symmetry. And when it has a regular shape that has 6 lines of symmetry, I'll just say LOS, if you take 360 divided by 6, that's the answer you'll get for the actual rotation symmetry as well. So if you take your 360 and divide by the lines of symmetry, you can also notice that that works as well. Watch. If I take a square, a rectangle here, that thing has a line of symmetry down the middle and a line of symmetry down here, oops, on that side as well. If you take 360 divided by the lines of symmetry 2, that's why it's also going to be 180, as you notice this as well. So lines of symmetry can then be divided into 360, and that will also give you the rotation, or the degrees of rotation symmetry as well. So that's what we have. So how far you turn something to get it to snap in place, that was a 60-degree turn, so it has 60 degrees, 180, 90, and so on. Hopefully that helps with that. And now lastly, we'll talk about translation symmetry. Translation symmetry works like this. You'll see repeated patterns, and in this case here, like wallpaper, tile work that you see in stores or places that you've been, they have what are called tessellations. These are the repeated patterns that go on forever, we assume at least, and then you can pick them up and move them in some translational direction, and then put them back down and still have the exact same pattern that you had before. So here's a piece of the pattern here that I'm going to show you that as I pick it up, I can take this thing and I can move it to the right if I want to, and it will still stay the exact same pattern. So there I go like this. If I move it like this, you can still see that the pattern is still there. I can move it diagonally also. I can move it down this way and still have the pattern maintained. So whenever you can pick up a pattern, slide it to a new direction, like a translation, it'll say we'll say that it has translation symmetry. Here's one more, a couple more just quick examples right here. You can see this one's got a weird kind of shape too as well to it. If I slide it to the right, eventually it will snap, or in some direction here, I can get it to go back to Let's see if I can find it here. Right about here. You can get these patterns that repeat. This one's a little hard actually to do. Let me find actually where that spot would. There we go. I could put it like right there, and that would be the pattern repeating as well. So you can take patterns, even like clothing that you wear. There's a lot of clothing. I've seen fabric like this before too, that has translation symmetry, and you can slide it in any new direction, and it will maintain the same pattern. So making sure you understand that I could slide it down here, for example. That pattern still stays the same pattern as I move it diagonally, horizontally, in whatever direction I want, or vertically. Lastly, there are some math, like a sine wave that we have here. This is actually a cosine wave, but as it moves up and down like this, I could pick this thing up and slide it in one direction horizontally also, and it would be the same wave repeated over and over. That's your translation symmetry. So as we're talking today, make sure you got an idea of all three translations, or of all three symmetries. We've got reflection symmetry, rotation symmetry, and transformation symmetry. Now, as you move on to your homework, keep these ideas in mind, and good luck.